Greatest common factors and least common multiples, section 5.4. The greatest common factor of a group of natural numbers is the largest natural number that is a factor of all the numbers in the group. Most often we find the greatest common factor of two numbers. However, you can find the greatest common factor of more than two numbers, and that is why the word group is being used. Finding the GCF using the prime factor method. Write the prime factorization of each number. Choose all primes common to all factorizations, with each prime raised to the least exponent that it has in any factorization. Form the product of all the numbers in step 2. This product is the greatest common factor. Use the prime factor method to find the GCF of 90 and 168. 90 factors into 9 times 10, which is 3 times 3 times 2 times 5, which is 2 times 3 to the second times 5. 168 factors into 84 times 2, which is then 42 times 2 times 2, which equals 21 times 2 times 2 times 2, which is 3 times 7 times 2 to the third. We have our prime factorizations of 90 and 168. There is 1 2 for 90 and 3 2s for 168, so we will take 1. Looking at the 3's, what they have in common, 168 has 1 3, 90 has 2 3's, we only take 1. There is a 5 as a factor for 90 and a 7 as a factor for 168, but they are not common. Our GCF is 2 times 3, which is 6. The least common multiple of a group of natural numbers is the least natural number that is a multiple of all the numbers in the group. Multiple, so it's going to be larger than the numbers we're starting with. Finding the least common multiple using the prime factor method. Write the prime factorization of each number. Choose all primes belonging to any factorization, with each prime raised to the power indicated by the greatest exponent that it has in any factorization. Form the product of all the numbers in step 2. This product is the least common multiple. Remember, the least common multiple is going to be larger than the numbers we're starting with. Use the prime factorization method to find the least common multiple of 90 and 168. Ninety factors into 2 times 3 squared times 5. 168 factors into 2 to the third times 3 times 7. We're choosing the largest that each one has. So looking at our 2's, we're going to go with 2 to the third. Looking at our 3's, 3 squared, have to include the 5 and the 7. 2 to the third is 8 times 9 times 35, which is 72 times 35. It's 2,520. Again, we can see that this least common multiple is larger than the 90 and the 168. Two movies start at 1 p.m. and run continuously. The first runs 80 minutes, the second 120 minutes. What is the next time the two movies will start at the same time? Let's look at our prime factorizations for 80 and 120. 80 is 8 times 10, which is 2 to the third, times 2 times 5, which equals 2 to the fourth, times 5. 120 is 12 times 10, which is 2 times 6, times 2 times 5, which is 2 times 2 times 3, times 2 times 5. It's 2 to the third, times 3, times 5. In this case, we are finding the least common multiple. Looking at our 2's, we need 2 to the fourth, times 3, times they each have 1 5, which is 240. 240 minutes equals 4 hours. 4 hours after 1 p.m. is 5 p.m. The movies will next start at the same time at 5 p.m. Josh has 450 football and 840 baseball cards. He wants to divide them into stacks of the same height with the same kinds of cards in each stack. What is the largest number of cards he can have in each stack? Let's start by finding our prime factorizations. And let's do 45 times 10, which is 9 times 5, times 2 times 5, which is 3 to the second, times 2 times 5 to the second. 840 is 84 times 10. 84 times 10 is 42 times 2 times 2 times 5. 42 is 21 times 2 times 2 times 2 times 5. 21 is 3 times 7 times 2 to the third times 5. If we write them in the correct order here, 2 times 3 squared times 5 squared, and 2 to the third times 3 times 5 times 7. We need to ask, are we looking for the greatest common factor or the least common multiple? The largest number of cards he can have in each stack is going to be less than 450 and less than 840. So we are looking for the greatest common factor. Our greatest common factor is 2 times 3 times 5, which is 6 times 5, which equals 30. The greatest number of cards in each stack is 30 cards. That's section 5.4, greatest common factor and least common multiple.